Hello everyone, I'm Mouna Rabhi, and today I will be presenting our work entitled FN2 Fake News Detection Based on Textual and Contextual Features. This work has been done with Dr. Bakiras and Dr. Roberto Di Pietro. Today's outline will be as follows. We will start with an introduction and we will present the related work in the field of fake news detection. We will also present our research objective. We will describe the proposed methodology and the experiments we have done. We then present the results and the findings, and we finish this presentation with the conclusion and future work. Nowadays, the majority of people get their news from online social media since it offers an easy and free access to news. According to a study done by the PEW Research Center, more than two-thirds of adults in US are getting their news from social networks. However, information can be shared on social networks without any check on its trustworthiness or accuracy, which has led to a significant increase in fake news circulation. Fake news is considered a threat to numerous fields including journalism, public health, democracy, and economy. It has a harmful effect on society and individuals. For example, during the 2016 US election, various false rumors about the candidates were widely spread on OSN platform and had a significant impact on the election results. So one can ask, what is fake news? Fake news is a news intentionally present a misleading information to the end user, and it is a basic tool to fuel propaganda. Therefore, detecting fake news is challenging for the following reasons. First, the fake news is intentionally made to misinform the reader. Therefore, it is not easy for the average OSN user to detect it. Second, social media data is massive, noisy, and consists of multitude of sources. To overcome these challenges, the research community have proposed automated detection models that are based on AI. The proposed solution can be divided in two categories: fake news detection based on textual feature and fake news detection based on contextual feature. The first category, fake news detection based on textual features, relies more on the news text. It focuses on the writing style. For example, the first work, LSTM, used the linguistic features such as the number of total words, the character per word, the frequency of large words, the number of unique words, and punctuation to detect fake news. The author have reported an accuracy of 56%. The second work employed a hybrid CNN-RNN model to detect fake news. First, the CNN model is used to extract local feature from the text input, and then the output of the CNN is passed to the RNN model, which learned the long-term dependencies of the local feature. The author has reported an accuracy of more or less 60%. The third work, Linguistic Inquiry and Word Count Model, is based on large lexicon of word categories that represent psycholinguistic process, summaries categories, and part-of-speech categories. More specifically, it reads an input text and counts the percentage of words that reflect different emotions, thinking style, social concerns, and even parts of speech. The extracted features are then passed to a machine learning model to learn classification. The authors report accuracy of 58%. The second category, fake news based on contextual features, make use of user profile feature and social context to classify news. For example, a hybrid CNN incorporated contextual news such as author, affiliation, source to detect fake news. The model takes two inputs, the news text and metadata related to this news text to classify news. The author classified the news into 6 categories, and they have reported an accuracy of 27.4%. However, the detection accuracy of the existing models is rather low, which limits their effectiveness. Moreover, few models have combined textual and contextual features, and even those who does are using contextual features that are not easy to collect in real case scenarios. To overcome the cited limitation, we aim to design a framework for fake news detection that uses both news text and news metadata. We aim to use explicit metadata that are already available. That is, we do not consider implicit profile features that are not there directly available in the user's raw data, such as personality, location, profile image, political bias, etc. This information requires a lot more effort to collect and can be easily manipulated. Moreover, we aim to demonstrate the effectiveness of contextual feature in classifying fake news, and we want to demonstrate that by combining textual and contextual feature, we can outperform the existing state-of-art models' accuracy. To this end, we propose a multi-model embedding framework that incorporates news text and contextual information to detect fake news. A representation of the model is shown here. As we can see, the model consists of two submodels. The first deals with textual feature learning and the second deals with contextual feature learning. In these slides, we will focus on the textual feature learning. So, before detecting the linguistic pattern from the news text, we perform a pre-processing step to clean the data, remove the redundancy, and filter out useless words. After eliminating noise, the text needs to be transformed into a vector of numerical values before being fed to the CNN model. In this work, we use BERT bidirectional encoder representation from transformers, which is a bidirectional pre-trained word embedding model based on multi-layer transformers and an attention mechanism that is capable of learning the contextual meaning of the words in a sentence. So in the second step, we input the pre-processed text to BERT and we obtain a vector representation of the text. Then we input the resulted vector representation to a CNN network to extract features. Now we will focus on the contextual feature learning. So for the contextual data, we will use source, which indicates where the document was published, for example, Twitter, Facebook, etc. Tags, which indicate the main topics stated in the news document. The author names, which indicate the name of the author of the article, and the author credibility, which reflects the reliability of the author of the article. Since most of the contextual data is textual, we will need to do a pre-processing step where we first split the feature into words, then we create a vocabulary for each contextual feature. Finally, we represent each word of the vocabulary with an integer in order to create a vector representation. This vector representation will be then fed to a neural network for learning feature. Finally, the two learned features obtained from textual feature learning and contextual feature learning are combined together using a sample concatenation technique in order to obtain a representation of the news document. The results presentation goes through a fully connected neural network and then a sigmoid dense layer to classify the news document. Next, we will present the architecture of the deep learning algorithm used for feature extractions. We will start with the textual feature learning. So after embedding the news text using BERT, we feed the vector representation to a CNN consisting of one-dimensional convolution layer followed by a max pooling layer for textual feature extraction. The convolution layer has 128 filters of size 10 and uses ReLU as the activation function. The resulting feature vectors are then fed into a max pooling 1D layer with a window size of 2 to downsample the dimensionality of the features and reduce the number of parameters. This approach aimed to decrease the computational costs without affecting the network efficiency. Furthermore, to avoid the overfitting, we add a dropout layer with the rate of 0.3. Finally, we use a flattened layer to transform the pooled features map into a one-dimensional vector. On the other side, to learn the metadata features, we have used two dense layers with 32 nodes each. We then added a dropout layer with a rate of 0.3 to avoid overfitting. Finally, the features from both CNN and FNN are concatenated and passed through a dense layer with 512 hidden nodes and then to a sigmoid dense layer to obtain the classification. For the purpose of this study, we have collected news from PolitiFact.com. PolitiFact is a fast-checking website where reporters and editors analyze the credibility of statements made by U.S. politicians. The evaluation score is organized over 6 qualitative levels, indicating the truthfulness of the statement, and it ranges from the true for accurate statement to pants on fire for false statement. For this study, we have collected 16,172 news, out of which 51.3 were labeled as true and 48.7 as false. We have grouped labels true, mostly true, half true to represent the true news, and the labels barely true, false, and pants on fire to represent fake news. Next, we present the results of our experimental evaluation that aims to investigate the accuracy of the proposed model FN2. Our main goal is to answer the following question: did FN2 improve fake news detection by combining news article with metadata? And the second is, how effective are the metadata in detecting fake news? To answer question 1, we compare our model against 4 competing approaches previously presented in the related work. We split the dataset into 80% training and 20% testing. We repeated the process 3 times. The average result is presented in this table. We noticed that FN2 achieved the best performances among all the other models. The accuracy of FN2 surpassed both textual-based model and hybrid model by a margin of at least 13% in terms of accuracy. FN2 performs better than the model using textual features. This indicates that the extracted used metadata features contain complementary information that helps boost fake news detection. And finally, FN2 outperforms competitors' models in terms of all the evaluation metrics. For example, FN2 achieves an improvement of 13% in terms of accuracy, 15% in terms of precision, and 14% in terms of recall comparing to CNN-RNN model. The performance gap is even more compared to the other models. Moreover, to illustrate the importance of metadata in detecting fake news and to answer question 2, we investigate the performance of 2 models of FN2. The first variant is FN2/CO and the second is FN2/T. The first variant, FN2/CO, is a variant that does not use the metadata, while the second is the variant that only uses the metadata to perform the classification. We note from this figure that when we remove the contextual information, the performance of FN2/CO decreased dramatically. In particular, both accuracy and F1 decreases by 17 and 16% respectively. This suggests that the contextual information bring important information to fake news identification model. Similar observation can be made for FN2O/T. When we eliminate the textual information from the classification model, one interesting remark is that FN2 performs slightly better than comparing to FN2/CO, suggesting that news metadata are at least as valuable as textual data. Therefore, we come to our conclusion is that the textual and contextual data of the news article are very valuable and they can contribute equally to the fake news classification problem. Thus, we can confirm that they contain complementary information. However, one of the main challenges that FN2 can face when using contextual features is cold start. In this work, one of the contextual features used, which is author credibility, can suffer from the cold start issue. In fact, when a new author joins the network, we have little information about its credibility. This may affect the prediction results of FN2. Therefore, we aim to study the impact of cold start of FN2. To do so, for an author that recently joined the network, we set its credibility to 0 since we do not have any history about its reliability. To evaluate the impact of cold start of FN2, we randomly set the author credibility for both training and testing to 0. So we randomly set 10%, 20% till 100% of the author's credibility to 0, and we observe the accuracy. As we can see from this figure, the cold start issue has slightly reduced the accuracy of FN2. For example, when we set the 30% of the author credibility to 0, FN2 reached 71.85% accuracy. And also we notice even when we do not have any credibility information about the authors, FN2 still outperforms its competitor by achieving an accuracy of 69.1. While this small impact of the cold start problem can be explained by the fact that the model uses both textual and contextual feature for detection. In other words, combining the contextual feature with the news text has significantly reduced the effect of the cold start problem. Finally, we aim to demonstrate the generality of FN2 model. To do so, we test FN2 on a fake news multidimensional benchmark dataset called Fake News Net. The dataset contains both political and entertainment news, collecting from two fast-checking platforms, PolitiFact and GossipCop. So the table shows the result of our evaluation. It first shows that our model is able to generalize on unseen data and outperforms the other models on the evaluation metrics. Moreover, it indicates that FN2 performs very well in non-political field. Indeed, FN2 was trained on political dataset, but it has also classified non-political news with an accuracy of 87.4%, outperforming all the other competitors. These results demonstrate that FN2 is able to capture the semantics of the data and can be applied in different fields. Finally, to sum up, in this work we have introduced FN2, an ML-based framework that combines both textual and contextual information to classify the credibility of news articles. Moreover, we demonstrated the correlation between fake news and contextual information, and we have showed that using contextual features improves the fake news classification accuracy by at least 13%. Further, we have shown that our model can quite generalize to other datasets even though it has been trained on political-oriented news. Finally, several interesting future directions can be further investigated. First, an extension of the FN2 model from binary classification to multi-classification will be considered in the future. Second, it will also be interesting to perform an analytical study of the quality of the results when converting multi-class labels to binary class labels. This will help us find the best binary split for the dataset that produce the best discrimination among the PolitiFact sublabels. Another interesting direction is to overcome BERT's limitation on the number of tokens, limiting our FN model to only news statement with less than 512 words. Therefore, we plan to extend FN2 to consider longer news articles. Finally, due to the lack of publicly available state-of-the-art fake news detection models, FN2 was compared only to 4 models. However, in the future, we plan to consider and re-implement more baseline for comparison. Thank you for your attention, and I hope you enjoyed the presentation.